Hello everyone, myself Dr. Vijayalakshmi Edali. Today in this video we are going to learn about classification and nomenclature of alcohols. Alcohol is a compound that contains one or more hydroxyl groups, that is alcohols are hydroxy derivatives of alkanes. Suppose, for example, from alkane, one or more hydrogens are replaced by OH group, then they are called alcohols. Alcohols are represented by general formula ROH. Here R is referred as any alkyl group. Classification of alcohols. The classification is according to the number of hydroxyl groups present as monohydric alcohols. The name itself indicates monohydric means one. It contains one hydroxyl group. For example, C2H5OH, ethyl alcohol. If more than one OH groups are present, then they are generally referred as polyhydric alcohols. But among that, if it contains two hydroxyl groups, then it is called dihydric alcohol. Example is glycol. Three OH groups are present, then it is called trihydric alcohol. Example glycerol. Monohydric alcohols are alcohols containing one hydroxyl group. So examples for monohydric alcohols, their common name and IUPAC name is given here. From methane, one hydrogen is replaced by OH group. So CH3OH, it is called methyl alcohol. In the common name, the alcohols are named as the corresponding alkyl group, and to that suffix alcohol is added. So here methyl group is there and suffix alcohol is added. This becomes methyl alcohol. But in the IUPAC name, one carbon meth, so it is methane. The suffix OL is added for alcohols, therefore it is methanol. C2H5OH, two carbons, ethyl group, so it is ethyl alcohol and IUPAC name is ethanol. Three carbons, CH3, CH2, CH2OH. So three carbons, propyl group, therefore it is propyl alcohol. But in the IUPAC name, three carbons, then it becomes propane. OH group is there, so suffix propanol. Or we can write propane 1-ol. The carbon which bearing the hydroxyl group is given number 1, therefore it is propane 1-ol. If the number is skipped also, it is okay, and it shows the hydroxyl group is present on first carbon. Let us see the last example. Here three carbons are there and the OH group is present on second carbon, and this is called isopropyl group, isopropyl alcohol. But in the IUPAC name, three carbons in a straight chain, then it is propane. The OH group is present on second carbon, therefore it is propane 2-ol. CH3, CH2, CH2, CH2OH, four carbons, butyl group, butyl alcohol, and it is butanol or butane 1-ol. If one suffix is not added, then it is known or understood that the OH group is present on first carbon. Dihydric alcohols are also called glycols, and these glycols are classified as alpha, beta, gamma glycols according to relative positions of hydroxyl groups. So alpha is 1,2-glycol. The common name for alpha glycol is derived from the corresponding alkene from which they may be prepared. Examples for glycols, alpha glycols, are 2 carbons and 2 OH groups are there. So usually the glycols are given name from which alkene they are prepared. So CH2, CH2, if CH2 double bond CH2, then it is ethylene. And this alcohol is prepared from ethylene, therefore it is ethylene glycol. But in the IUPAC name, 2 carbons are there in the straight chain, therefore it is ethane. On first carbon and second carbon, OH groups are present, therefore it is ethane 1,2-diol. In this glycol, 3 carbons are there, so it is propene glycol. In the IUPAC name, propane 1,2-diol. So this is first carbon, second carbon and third carbon. The carbon bearing OH group is given lowest number. Therefore, first and second carbon numbers are given as which bears the OH group. Propene 1,2-diol. This, the carbon which bears the OH group, adjacent to that, this is alpha carbon. Therefore, it is alpha butene glycol. The OH group is present on alpha carbon, alpha butene glycol. But IUPAC name, butene 2,3-diol. In this, 4 carbons are there and one, but they are not in the straight chain, branched, therefore isobutene glycol. But in the IUPAC name, only 3 carbons are in the straight chain, therefore it becomes propane. On first carbon and second carbon, OH groups are present, therefore it is 1,2. 2 OH groups, diol. And on the second carbon, methyl group is present, therefore it is 2-methyl propane 1,2-diol. Beta and gamma glycols are named as corresponding polymethylene glycols. Means the number of CH2 groups present. More than one CH2 group, then it becomes polymethylene glycols. CH2 group is called methylene group. So in this structure, there are 3 CH2 groups are there. So it is trimethylene glycol, or corresponding to the first carbon which bears the OH group. Next, that is alpha and this is beta carbon. Therefore, the OH group is present on beta carbon. It is beta propylene glycol. And the IUPAC name, propane 1,3-diol. In this, 4 carbons are there in a straight chain. And again, the alpha carbon and beta carbon. So OH group is present on beta carbon. It is beta propylene glycol, or also called 2,3-butylene glycol. But in the IUPAC name, 4 carbons in the straight chain butane. First carbon and third carbon contains OH group. So 1,3-diol. So here, with respect to the carbon bearing OH group, adjacent to that it becomes alpha, next one is beta, next is gamma. So here, first carbon and gamma carbon bearing OH group. Therefore it is gamma butylene glycol or tetramethylene glycol. IUPAC name is butane 1,4-diol because on first carbon and fourth carbon OH group are present, therefore it is butane 1,4-diol. Trihydric alcohols. In the trihydric alcohols, which contain 3 OH groups, are called trihydric alcohols. So in this example, 3CH means 3 carbons which contain 3 OH groups, and its common name is glycerin. You may heard the name glycerin, which is frequently used in all cosmetics, that is in the preparation of soaps and other cosmetics, glycerin is used. This glycerin is obtained by alkali hydrolysis of oils or fats. So it is a derivative, it is obtained by alkali hydrolysis of oils and fats. But in the IUPAC name, 3 carbons are there, therefore it is propane. 1, 2, 3, all the carbons BS the OH group, therefore it is 1, 2, 3 triol. 3 OH group, therefore triol. In this also 4 carbons are there, and first, second, third carbons BS the OH group, therefore it is 1, 2, 3 trihydroxybutane. But in the IUPAC name, butane 1, 2, 3 triol. So this is about the examples of trihydric alcohols and their nomenclature. So common name may be different, but in the IUPAC name, one rule is referred. So corresponding alkane name is taken, and then the position of OH group on which is OH group present on the carbon, that position is given. Then if 1 or 2 or 3 OH group, depending on that, diol, triol, like this names are given. If 4 carbons, tetrol, pentanol, hexanol, like this. So they are examples for next polyhydric alcohols. So if more than one OH group, they are usually referred as polyhydric. Among that, if 2 are there, dihydric, 3 are there, trihydric, 4 tetrahydric, pentahydric, like that. So for example, carbohydrates, they contain minimum 2 OH groups. So carbohydrates contain 3 OH groups, 4 OH groups, 5 OH groups, 6 OH groups are present. So hexanol, pentanol, like that, the names are given. So I think you learned about the nomenclature and classification of alcohols. In the next video, we'll see the preparation of alcohols.